Hello, I am Ibraheem Moalla from Syria. I'll be presenting to you my research about the investment of magnetic power for better seismic isolation technologies. We will start with the introduction. Seismic isolation technologies are becoming a necessity of any building these days due to their ability to make the building more capable of withstanding powerful earthquakes. The action mechanism of these technologies is the dissipation of seismic shocks energy by decreasing the structure's vibration frequency. So, the building will not resist the seismic vibrations, which mean keeping the building steady despite the changing circumstances that surround it. Nowadays, there are two main seismic isolation technologies which are mostly used and proved to be efficient enough. The first one is using earth isolators, which is a good way to protect the building from collapsing as a result of earthquake. This technology depends on isolating the structures by building it on springs. However, the building will only oscillate horizontally in a slow cycle during earthquakes. Therefore, damage to people and buildings can be prevented comprehensively. And the second technology is using flexible junctions, which depends on using flexible junctions made by elements that have the ability of absorb the seismic shock's energy because it's low friction power, like elastic. Nevertheless, these elements aren't permanent, so the junction will not be able to absorb the seismic shock's energy when these elements erode. Why we choose magnets? We choose magnets for three main reasons which made it the most suitable material for use in seismic isolation technologies. First reason is our ability to control the magnetic power. Like everybody knows, we can adjust the power of the magnetic field to suit with the earthquake power by passing the appropriate electric current through the coil or wire. And the second reason is that the magnets can be permanent by supplying them by the electric current that they need. And the third reason is repulsion and attraction power. These two forces can be used to increase the building's ability to withstand powerful earthquake. Supplying Earth's isolators by magnets. Our way depends on placing two magnets beneath the building and on the earth. Thus, we can benefit from repulsion and attraction power to increase the spring's ability to dissipate seismic shocks. Magnetic junction. Our way is based on replacing the flexible layer in the flexible junction with magnets. However, we use SolidWorks program to make an illustration of this junction. We use 8 magnets, and every two opposite magnets face each other with the same pole in order to stabilize the junction. The action mechanism is when an earthquake hits, the junction moves in a specific direction which is determined by sensors. However, if the earthquake's power is greater than initial power depends on magnets, the electric current passing through the opposite magnet is reversed to attract the junction, bringing it back to its initial position. The study shows that the building will collapse if the lateral movement of the junction is greater than d, the distance between two opposite magnets. Here d is 0.5. However, the simulation shows that the lateral movement of the junction is always less than 0.5. So, if the building foundation are able to stabilize the junction during its motion, so the building can withstand the earthquake. We conclude with results. Using magnets in seismic isolation technologies increases its ability to dissipate seismic vibrations, which make the building more capable of withstanding powerful earthquakes. References. And thank you for your listening.